again!
Is this possible using physics? Let's dive into it. So let's go ahead and rephrase this as a physics question. Did the reporter land with enough force to break the car's windshield?
So here's a free body diagram of the man as he's thrown. We see the force of throw on the man, force of gravity on the man. Here's a free body diagram of when he's in the air. We see there's a force of gravity on the man. Note that there's no force of air resistance. So this is the free body diagram of the man as he gets the windshield. This is the force of gravity and the force of the windshield.
So what exactly are we trying to find here? Well, we're trying to find the force in newtons of the reporter colliding with the windshield. We can then compare this to the minimum force that would be required to break the vehicle's windshield. So how exactly are we going to be finding force during impact? Well, since we're looking for units of newtons, and newtons can be written as kilogram meters per second, we can be finding our answer using impulse. So now that we know that we're going to be calculating for impulse, what exactly do we need to find? Well, we need to find the momentum change on impact, which is delta p, and the change in time during the collision. Let's solve for delta p first.
So let's find what delta P is. Since the collision was perfectly inelastic, we can calculate delta P using the equation P equals mv. The mass, or m component, is going to be the weight of the stuntman Rick Avery, who weighs 70.8 kilograms. We need to solve for the velocity, or v component. We can do this using kinematic equations.
Okay, to calculate for velocity, we know that he's going to collide with the vehicle at an angle, so we're going to need an x and y axis of it. So let's use the y direction velocity first. So let's find what y velocity final is. We can use this kinematic equation. We need to find time.
We can solve for time by finding the number of frames between the stuntman being thrown and his eventual collision with the car. We can then divide this by the frame rate. So we can see when he's first being thrown, we're at frame 111, and when he impacts with the windshield, we're at frame 162. Simple subtraction gives us a difference of 51 frames, and if we divide this by the frame rate, which is 24 frames per second, we find that the time that he's in air is 2.13 seconds. So now we can go ahead and calculate velocity in the y direction. See now that we have our time value in the bottom left. Plugging it into this equation, now all we need is to find the initial velocity. So let's use this equation to find that. Using this kinematic equation, we see that we're still missing y displacement. So let's go ahead and find that. We're going to start off with our initial y value, and this is David Koshner's shoulder height.
We're going to overlay these two values, and we're going to find that the ratio between them is 0.814, and we're going to multiply that by his total height, which will give us a 1.53 with meters, which is going to be his shoulder height. Find y final. According to the vehicle specifications, Chevrolet Camino, the total height from the ground is 62.7 inches. So what's the height of the point of impact? The red line right there. We're going to overlay them again, and we're going to do the same thing. We're going to find the ratio of 0.757 times that, and 0.757 times 1.59 is 1.2 meters.
Well, now we can find the final y velocity. Using these kinematic equations, we can solve for the final y velocity, which is negative 10.6 meters per second. And now we need to find the velocity in the x direction. Let's find what the velocity of x is. Using the equation, we can we're using our time from before, which is 2.13 seconds, to find the x displacement.
Okay, now let's find the thrown distance, displacement x. We're going to use this guy in the gray suit back here, Chris Parnell. So this is the distance from Chris Parnell to the wall. The wall here is lined up with the car, so we can use it. Chris Parnell is 1.73 meters tall, and we can use that as a reference. Each one of these yellow lines equals 1.73 meters Parnell's height. We find that it is slightly more than 1.73 meters to get there, so we have to find out what this is. Using ratios, we find that it is 0.173, so we subtract that from the total, 5.19, to find 5.02 meters as the x displacement. With this displacement, now we can calculate the velocity in the x direction, and it'll give us 2.36 meters per second. And now we're going to solve for the initial velocity, which is the same, because there is no acceleration in the x. Now we can find the final velocity vector.
And we can go ahead and do this using the Pythagorean theorem. Solving for the resultant vector, we get that it is 10.9 meters per second. And now we can finally find momentum, since we have both mass and velocity. And this calculates out to be 812.29 kilogram meters. Plugging this into our impulse equation, which is delta p over delta t, we know that delta t is going to be 0.04 seconds because that is the length of one frame in the movie, and the collision only occurs for one frame. So plugging in both of these values, we find that impulse is going to be 20,307.25 newtons, or considering significant figures, 20,300 newtons.
So is it enough? So 20,300 newtons is more than enough to break a windshield, which is standard grade safety glass, which takes, in fact, 2,000 to 2,100 newtons to shatter. In fact, it's nearly enough to lift up the car.